Alright, problem number 73, we have a tablecloth that's going to be pulled from under some dishes. We want to know how far are the dishes going to move during the 0.25 seconds it takes to pull out the tablecloth. And we're told the coefficient of kinetic friction between the cloth and the dishes is 0.12. So we'll pick the dishes, or rather maybe a dish. And forces acting on the dish will be force normal from the tablecloth. Force due to gravity. And we'll say force of friction. Tablecloth would be force due to gravity. Force normal. Now I'm going to call this one D from the dishes. Force normal, we'll call this T from the table. We'll call this F from the pole. This will be force of friction. And this friction will be with the dishes. And we'll have a little bit more friction probably with the tabletop. Alright, so what you're actually touching with the pulling force is the tablecloth. The dishes, what accelerates the dishes is the force of friction. Because the only things interacting with the dishes or touching the dishes are gravity, acting on the dish itself, the normal force, which comes from the tablecloth, or I called it D here, is the dish tablecloth interaction, and the friction with the tablecloth and the dish between those two surfaces. All we really care about is the dish, so we're going to say sum of forces in the x direction is force of friction of the dish. Sum of forces in the y direction, force normal, from the dish, or between the dishes and the tablecloth, plus force due to gravity of the dishes. That's AX, this is AY. This one is movement confined to the surface. Since the movement is confined to the surface, my acceleration in my y direction will be 0, right? I won't be launched off of the tablecloth, nor I'm going to be falling through the tablecloth. What that tells me then is my force normal for the dish is the force due to gravity. My force of friction is my coefficient times my force normal, which in this case is coefficient times force of gravity. Now force of gravity is going to be, maybe I should write that up here, mass of the dish times g. So put the mu in front there. There we go. Mu mg will be my force of friction. So mu mg is equal to ma, x component. Notice I don't need to know anything about the mass of my dish, and I could say that my acceleration experience then is just the coefficient times gravity. And the coefficient I'm given 0.12. Gravity I know, 9.80 meters per second squared. Oops, squared. And I can plug that in my calculator and get a number. So 0.12 times 9.8 gives me 1.176. Now think about what's happening with the dishes. So I have initial velocity of the dishes is 0. Final velocity, is that what I want to know? Let's see. Nope, I want to know how far are they going to move. Okay, so I don't care about that part. Initial position, I'll say is 0. Right, I'll define them to be at the origin initially. I want to find where are they going to be. That's the question mark. That's what I want to know. And my time interval is going to be 0.25 seconds. My acceleration, 1.176 meters per second squared. Well, I look through my equations and see which one I have for this case, and it looks like I have this one. Don't have an initial velocity. My initial position is also 0. So what I want to know is 1/2 of my acceleration, 1.176, times my 0.25 seconds squared. And that should give me the answer I'm looking for. Oops. Alright, I'm going to pause this. My calculator is being weird. Alright, got my calculator to work, and so we get 0.0368, or we could say 3.7 centimeters. And it looks like we've answered the question. It asked how far does any one of those dishes that happens to be on the table move? And so that's how far it's going to move, 3.7 centimeters.